Welcome. In this video, we'll do a second example using the quotient rule. Here we have a function y, which has a function in the numerator and in the denominator. So this is a perfect case to use our quotient rule. If I take a derivative of this function y, I'm really considering this as the derivative of the y function with respect to x. So we call that dy dx. So let's consider how we're going to take this. We want to start with the denominator every time, take the derivative of the denominator, and rewrite the numerator. So the derivative of the denominator we'll find is 18 x squared minus derivative of 5 to the x power will be 5 to the x, natural log of the base, which is 5. So there we have the derivative of the denominator, times, we'll take a look at the numerator function. We'll just want to rewrite that numerator function to start. So that's 3e to the x plus 4x to the negative 2 power. Next, in our numerator here, we want to subtract the denominator function. So we'll subtract the denominator function, which here would just be 6x to the third power minus 5 to the x, no derivative on that. And then the last thing, let's do the derivative of the numerator. So 3e to the x in the numerator gives me still 3e to the x. The derivative of e to the x doesn't change, and the constant comes along for the ride. So we have 3e to the x. And then we have a power term, 4x to the negative 2. I can bring that negative 2 down as a multiplier, so my multiple becomes negative 8. And my exponent, if I subtract 1 from negative 2, becomes a negative 3. And I'll end that parenthesis. And the final thing we have to look at is dividing everything here by the denominator squared. So we'll take this denominator function, 6x cubed minus 5 to the x power, and I'll put a bracket around all of that and square it. So there's a lot going on in this final derivative, but hopefully walking through these steps is helpful. So thanks for watching, and I'll see you in the next video.